In this video, I'm going to explain how to express values in terms of I, because when we have square roots of negative values, we don't want to leave it that way. We want to express it in terms of I. And what I mean by in terms of I is I kind of mean the same way in geometry when we expressed values in terms of pi. We didn't multiply the pi 3.1415 and so on times anything. We just kept things as like 16 pi, 5 pi, 2 pi, for example. So we're going to have values such as 3i, negative 3i, the square root of 2i. Those types of things is what we're going for here. We have four main tools that we're going to be using. One that states that if we have the square root of some number that has different multiples, we can split it up. We can also go the other direction too. If we had the square root of a times the square root of b, we could multiply a times b and put under one radical, or we could go the other direction. This direction is going to be much more valuable for us, where we make one of these, probably our b is going to become the square root of negative 1. So we're going to take that guy out and then turn it into I. We're going to use the fact that I is equal to the square root of negative 1, so that when we're done this step up here, we can turn it into I. That's going to be the connection right there. Another thing that we're going to be using, or another tool that we're going to use, is the fact that multiplication is what we call commutative. I can change the order and it doesn't matter. A times b is the same as b times a. I can write it with more variables, doesn't matter the order. So we're going to rearrange some things to make them make more sense. And the last thing that we've learned in the past is that square rooting and squaring cancel each other. So if they're within the same problem, all they do is cancel out each other. All right, let's take a look at our first example. In our first example, we have the square root of negative 7. The first thing that I notice is that I don't know the square root of any negative numbers. I certainly don't know the square root of even positive 7. So there's only so much that I can even do with this problem. So let's take a look at what we can do. We can split up that negative 7, and we definitely want to be able to take out an I, because that's what it means to be in terms of I. So I'm going to rewrite this as the square root of negative 7. Actually, I'm going to make it the square root of just 7 times negative 1. And then I can split up my square root. It becomes the square root of 7 times the square root of negative 1. And as we learned, or as we reviewed in our tools, the square root of negative 1 is just I. So now I can rewrite this for my final answer as the square root of 7I. All right, and we do put the I at the end after all of the numbers that it multiplies by, because all things in the what's called the complex number system are all of the form a plus b I, where a and b are rational numbers. Well, they're actually real numbers. They don't have to be rational. They can be irrational. So they're actually real numbers. Okay, so that's what all of our answers should look like, is a plus bi, where a and b are some kind of numbers, whether they're square roots or otherwise. So this right here, it matches our form. Let's keep going. All right, problem number 2. So in problem number 2, we have a coefficient, or a constant, outside of our radical. We're going to go through the same steps that we went through before. We're going to split up our negative 10, and we're going to make it 2 times a positive 10, and I'm just going to split it up right away, times that negative 1. I already know that that negative 1 is an I, so I get my final answer, 2 times the square root of 10 I. Now, if I could take the square root of 10, I would. If I could simplify it anymore, I would also try to do that, but 10 is made up of just 2 and 5. So there were no pairs in there, so everything stays the same. All right, moving on to example number 3. And in example number 3, we have the square root of a negative perfect square. That should be easy enough. We're going to do the same thing we've been doing, which is split up our square root into the square root of that positive number times the square root of negative 1. We know that that square root of negative 1 is I. Do we know the square root of 25? I sure hope so. It's 5. So we get our answer of 5 times I, or just 5i. And yeah, we always do make our I cursive. I don't know why, but we do. All right, example number 4. All right, in example number 4, we have that squaring and square rooting, and it just cancels each other. So the square and the square root cancel, and we just get negative 30. It's that easy. It's just the number in there. So it's just like we learned when we were in square root equations, when squaring and square rooting canceled, still applies. On to number 5. All right, problem number 5. This makes us split it up, and then something will cancel is what's going to happen in this problem. Let's take a look. All right, so the square root of negative 10, that's the one that we don't like. That is the square root of 10 times the square root of negative 1 over the square root of 2. Now, we can replace the square root of negative 1 with our I. And we can keep everything else the same, and we're almost there, but we're not quite there. Now, we've expressed it in terms of I, which is great. It'll probably get you almost all of the credit because you've done what's assigned. You've expressed it in terms of I, you've taken out the negative inside of the square root. But we still can simplify this more. So we can do at this point, and this would earn you full credit, is I'm going to split up the square root of 10 now into the square root of 5 times the square root of 2, all times I, divided by the square root of 2. And now we can cancel our square roots of 2, and we get an even better answer of the square root of 5 times I, or just the square root of 5i. Is how we would say that. Okay. So again, this answer has accomplished what we were looking for, but this answer right here is just the most simple it could get. Also, we're going to learn in future math lessons that having a denominator with a square root symbol in it is not really kosher. All right, on to example number 6. All right, in example number 6, oh boy, it's got the square, it's got the square root. It's making us think that we should probably just cancel them and give an answer, but then there's that number on the outside of the square root. I bet that screws everything up. So let's just take this one step at a time. Now, when I was in school, people were squaring all sorts of crazy things in their heads, but I always wrote it out because it helped me to visualize everything and allowed me to use the commutative property, which we were taking a look back in our 4 main tools. Number 3 right here is we can change up the order, so we definitely want to use that to make things easier on our brains. So here we have 2 times the square root of negative 9x all squared. Let's write that out. So when we square something, that means it's multiplied by itself. So we have 2 times the square root of negative 9x multiplied by itself. That's me being real lazy there, but it's exactly itself. I just really wanted to make that point that I just cloned it. That's exactly itself. And on the inside of each one of these parentheses, I'd also like to point out that this 2 is being multiplied. There's an inherent multiplication sign by that there, and this 2 is also being multiplied. So all 4 of these terms, 1, 2, 3, and 4, are all being multiplied together. And we know that we can change the order, so what we're going to do is move the numbers, the constant terms that don't have radicals next to each other, we're going to move them next to each other, and we're going to move our radicals next to each other, and then hopefully we notice even more things about what's going on here. All right, so I have my 2 next to my other 2, That's going to make things easy because that's just going to be 4. And then we have the square root of negative 9x times the square root of negative 9x. Ooh, but now we could rewrite that as squared. And that'll help us. So it actually becomes, we can do this, that goes to 4. And then we'll just do it like this, square root of negative 9x squared. Interesting. And we know from previous examples and from our last topic that these two things cancel, leaving us with 4 times negative 9x. But we can multiply those. So let's go ahead and multiply to get negative 36x. That problem looked pretty terrible, but once we changed the order right here, things got a lot easier. So just remember, when you're multiplying, you can change the order. Let's take a look at our last example, number 7. All right, so in example number 7, we have some negative value, and another value, and neither of them have square roots. Well, when in doubt, the first thing that we could check is what happens when we recombine them. So just like we could split them up like that, what happens if we combine them back together? So if I multiply the 45 times the 5, I get 225, and that's negative. Oh, wow, that is definitely a perfect square. So what I'm going to do at this point is I'm going to actually split it up a little differently. So before they had it as negative 45 and 5, I'm going to split it up as the square root of 225, which has a square root of 15, and negative 1, which we know is just I. So then we get our answer of 15I. And that's how you will write values in terms of I. Things to keep in mind if you didn't necessarily notice that squaring undoes square rooting is you're going to want to keep that initial value of I rotation in mind, where I to the first power is equal to I, which is the same thing as the square root of negative 1. I to the second power is the same thing as the square root of negative 1 squared, which is negative 1. I to the third power is just I times I squared, which is equal to I times negative 1, which is negative I. And lastly, we had I to the fourth, which is I squared times I squared, which is negative 1 times negative 1, which is positive 1. So you're going to want to keep this initial rotation in mind if you get I raised to values, especially if it goes more than 4. You're going to have to remember that other lesson that I did on I raised to powers.